In the infinite expanse of the universe, where stars glitter like scattered diamonds, there exist silent realms cloaked in darkness, shrouded in an eerie mystery that defies human understanding. These are not the galaxies you admire through a telescope or dream about exploring. These are dark galaxies, ghostly, unseen entities that hold no light, no beauty, only questions that unsettle even the most brilliant minds in astrophysics. What secrets lurk within these shadowy voids? Could they harbor forces capable of unraveling our understanding of the cosmos? Stay with us as we delve into the 25 most chilling and elusive dark galaxies that scientists not only struggle to comprehend but, in some cases, fear. What makes them so terrifying? Join us as we uncover the cosmic enigma that could reshape everything we think we know about the universe. Now turning to our first dark galaxy, Virgo He21, a name that might not inspire fear at first, but its characteristics certainly do. This enigmatic entity resides in the Virgo cluster, a massive congregation of galaxies that is already a puzzle in its own right. Virgo He21, however, stands apart for being almost entirely devoid of visible stars. Unlike the glowing spirals and clusters we typically associate with galaxies, this one is cloaked in near-total darkness. But here's where it gets even stranger despite its lack of starlight. Virgo He21 emits a powerful hydrogen signal, which is how scientists originally detected it. Hydrogen is often a precursor for star formation, so why does this galaxy remain a barren void? The answer might lie in its staggering composition, which is believed to be dominated by dark matter. This invisible substance, which neither emits nor reflects light, is thought to make up most of the universe's mass, yet it remains one of the greatest mysteries in modern science. Virgo He21's unusual behavior raises profound questions about how galaxies form and persist. Typically, the gravitational pull of dark matter attracts ordinary matter, leading to the birth of stars. But here, it seems dark matter has taken control, suppressing star creation entirely. Scientists are left grappling with the possibility that this galaxy could represent an entirely different evolutionary path for cosmic structures. Could Virgo He21 be a missing piece in the dark matter puzzle, or worse, a sign that our understanding of galactic physics is incomplete? As we ponder these unsettling ideas, let us journey further into the cosmos to uncover even more baffling phenomena. As the next enigma unfolds, we encounter Dragonfly 44, a galaxy that has left scientists both astounded and deeply unsettled. Nestled in the Coma cluster, this galaxy stands out for a staggering reason. An estimated 99.99% of its mass is composed of dark matter. To put that into perspective, dark matter dominates the universe, but nowhere else has it been found in such an overwhelming proportion. Unlike most galaxies, where stars, gas, and visible matter provide a clear structure, Dragonfly 44 is nearly invisible, its faint light barely betraying its massive presence. The implications of this discovery are nothing short of extraordinary. How does a galaxy end up being almost entirely dark matter with so few stars to illuminate its existence? One theory suggests that turbulent conditions during its formation may have prevented traditional star creation, leaving behind a structure largely governed by the gravitational force of dark matter. Another proposes that Dragonfly 44 could be a vast remnant of a galaxy stripped of its stars through violent cosmic collisions. Whatever its origin, this galaxy defies the models of formation we have long relied on. The sheer dominance of dark matter here forces scientists to re-examine their understanding of how galaxies evolve and sustain themselves. Could this be a glimpse into an alternative type of galactic structure, one that operates under wholly different cosmic rules? While Dragonfly 44 remains a window into the mysterious nature of dark matter, it also serves as a chilling reminder of how much we still do not know about the fabric of our universe. Now, let us journey further to unravel another shadowy revelation in the cosmic tapestry. With the next phase of the journey in sight, let us turn our attention to the Andromeda galaxy, our cosmic neighbor, and home to a haunting collection of ghost galaxies. Unlike their luminous counterparts, these dark galaxies hover in near invisibility, their faint presence betraying almost no light or structure. What makes them ghost-like is their apparent lack of stars, leaving only faint traces detectable by the most sensitive instruments. These dim companions to Andromeda raise unsettling questions about what else might be lurking undetected in the vast expanses of space. Scientists stumbled upon these elusive entities while studying Andromeda's immediate surroundings, and their discovery has been anything but straightforward. Their minimal light output means that traditional telescopes, which rely on visible light, struggle to capture their presence. Instead, researchers have to hunt for subtle gravitational effects or rely on advanced techniques to tease out faint signals such as hydrogen emissions. This level of difficulty in detection suggests that many more dark galaxies might exist, quietly lingering beyond our observational grasp. Adding to their mystery is the potential role they play in shaping the structure of the universe. These ghost galaxies are thought to be dominated by dark matter, an invisible substance that binds galaxies together through its gravitational pull. If Andromeda's dark companions are any indication, there could be countless other unseen structures influencing the cosmos in ways we can hardly imagine. Their existence challenges our assumptions about galaxy formation and raises the unsettling prospect that most of the universe's structure exists in a form we cannot directly observe. These shadowy companions of Andromeda remind us of just how incomplete our understanding of the universe truly is. They serve as hidden pieces of an endless puzzle, urging scientists to press forward in their quest to illuminate the unseen. As we leave this spectral collection behind, prepare to encounter yet another dark marvel in humanity's ongoing exploration of the unknown. As we venture deeper into the unknown, let us uncover the perplexing enigma of LEDA 074886, a galaxy unlike anything else in the observable universe. This celestial oddity stands out for its striking rectangular shape, a feature that defies the typical spirals, ellipses, or irregular forms we associate with galaxies. This geometric anomaly is not just a visual curiosity, it challenges the very principles of how galaxies form and evolve. What celestial forces could carve out such an angular structure in a cosmos where curves and chaos usually reign supreme? Some scientists speculate that its peculiar shape may be the result of a violent cosmic collision or merger with another galaxy, a cataclysmic event that tore apart its original form and reshaped it into something extraordinary. Others hypothesize that unseen forces, such as dense pockets of dark matter or the gravitational pull of nearby galactic structures, could be influencing its unique appearance. The exact mechanisms remain a mystery, leaving astronomers to piece together clues from limited observations. Adding to the intrigue, LEDA 074886 may hold vital information about the forces that mold galaxies across the universe. Its abnormal structure raises the question of whether such shapes are fleeting results of rare cosmic events, or if there could be more rectangular galaxies lurking in the shadows, waiting to be discovered. Each observation of this galaxy adds another layer to our understanding, or perhaps to our bewilderment regarding the interplay of visible matter, dark matter, and the processes that govern galactic formation. LEDA 074886 is more than just a geometric oddity. It is a stark reminder of how much we have yet to learn about the universe's creative and destructive powers. As we move beyond this angular enigma, prepare to delve into the next dark galaxy where the mysteries only deepen. Moving forward, let us dive into the enigmatic realm of AGC 229385, a galaxy cloaked in darkness despite its abundant hydrogen gas. At first glance, one might expect this galaxy to be teeming with the bright, radiant stars that hydrogen typically gives rise to. However, this is not the case. AGC 229,385 challenges our fundamental understanding of star formation, as its vast reservoirs of hydrogen seem to remain dormant, refusing to ignite the stellar birthplaces we usually associate with such material. Scientists are left wondering what could possibly suppress the natural processes that spark the creation of stars. One theory suggests that the conditions within AGC 229,385 might lack the necessary catalysts such as sufficient gravitational pressure or shock waves that facilitate the compression of gas clouds into stars. Alternatively, perhaps its hydrogen is spread so thinly across the galaxy that the density required for star formation simply cannot be achieved. Another possibility is that unseen factors, possibly connected to dark matter or other unknown cosmic forces, are actively preventing the galaxy from lighting up. These unanswered questions make AGC 229,385 a puzzle that continues to confound even the brightest astronomers. Adding to the mystery is the fact that AGC 229,385 is incredibly difficult to observe. Without the usual starlight to give it away, this galaxy remains nearly invisible in traditional optical wavelengths. Astronomers rely on sensitive instruments that detect radio waves emitted by the hydrogen itself to map its presence. This limitation raises an unsettling thought. How many other galaxies like AGC 229,385 might be lurking undetected, hidden in the cosmic void simply because they do not shine like their more luminous counterparts? Could these dark galaxies represent an entirely overlooked aspect of our universe? The existence of AGC 229,385 and others like it serves as both a challenge and a caution to scientists. It reminds us that the universe is far more complex than our current models can fully explain. Every discovery unveils new layers of questions, pushing us to rethink the principles we once considered universal. As we leave behind the dormant mystery of AGC 229,385, our journey propels us toward an equally haunting presence, a ghostly giant merging with our very own galactic backyard. With the next chapter of our cosmic exploration in focus, we encounter Andromeda 2, a faint and sprawling galaxy often referred to as a ghost galaxy. This is not just a poetic nickname. Andromeda 2's dim, almost invisible nature makes it eerily elusive, even with advanced observational tools. Nestled on the outer edges of the Milky Way, it is merging with our galaxy in an interaction that has scientists both intrigued and concerned. What makes Andromeda 2 truly remarkable is its sheer size, nearly as large as the Milky Way itself, but with only a fraction of its brightness. Its sparse stars are spread so thinly that detecting this galaxy has only been possible through the effects of its gravitational pull rather than its light. Andromeda 2's ghostly features are not the only reasons it stands out. Its ongoing merger with the Milky Way has potential implications that scientists are closely monitoring. As the two galaxies interact, the gravitational forces exchanged could disrupt the delicate structure of the Milky Way, potentially altering the orbital paths of stars or even triggering waves of star formation in certain regions. These types of galactic collisions, though slow and sprawling over millions of years, can reshape entire galaxies in ways we are only beginning to understand. The idea that Andromeda 2, with its colossal but dim presence, is silently influencing our own galaxy adds an unsettling edge to its enigmatic profile. What puzzles scientists even further is the role that dark matter might play in the dynamics of Andromeda 2. It is hypothesized that the galaxy is encased in an unusually diffuse halo of dark matter, which could provide the gravitational glue holding its faint structure together. This raises questions about whether its dark matter halo might significantly affect the Milky Way during their merger, potentially adding to the complexity of the interaction. Could this faint, ghostly galaxy be hiding far more influence in its shadowy depths than its dim light reveals? Antlia too serves as a chilling reminder that the universe operates on scales and forces beyond what we can easily perceive. As astronomers continue to study its quiet yet monumental impact on the Milky Way, they are left to wonder if other ghost galaxies might also be lurking unnoticed, waiting to challenge what we think we know about galactic evolution. These discoveries remind us that in the vast cosmic ocean, even the faintest ripples can create waves of change. Our attention now shifts from the haunting presence of Antlia II to a galaxy that defies all expectations of what a galaxy should be, a place where dark matter seems to have mysteriously vanished. As the cosmic narrative takes an unexpected turn, we arrive at NGC 1052 DF2, a galaxy that has left scientists both baffled and deeply intrigued. What sets this galaxy apart is not its size or brightness, but the shocking observation that it appears to be almost entirely devoid of dark matter, the mysterious substance thought to make up most of the universe's mass. This discovery is nothing short of revolutionary, as dark matter is considered a fundamental building block of galaxies, acting as the gravitational framework around which they form and evolve. The absence of dark matter in NGC 1052 DF2 challenges this long-standing assumption, forcing scientists to rethink the very principles of galactic formation. The first observations of NGC 1052 DF2 left researchers stunned. Unlike typical galaxies whose movements and structures are strongly influenced by the gravitational pull of dark matter, this galaxy's stars display motions that can be fully explained by visible matter alone. Such a finding sparked heated debates within the scientific community, raising questions about whether dark matter is truly a universal ingredient of galaxies, or if exceptions like this reveal gaps in our understanding. Some theorists propose that the unique environment surrounding NGC 1052 DF2 might have stripped away its dark matter over time, while others speculated could be evidence of entirely new cosmic processes we have yet to comprehend. What makes NGC 1052 DF2 even more significant is the ripple effect it has on broader questions about the universe. If dark matter is not a prerequisite for galaxy formation, could there be countless other galaxies out there, faint and undetected, that defy our expectations? Or could this galaxy, with its absence of dark matter, hint at alternative explanations for the invisible forces shaping the cosmos? These unsettling possibilities challenge the comfort of established theories and remind us how little we truly know about the universe's hidden mechanisms. NGC 1052 DF2 stands as a celestial enigma, both awe-inspiring and deeply unsettling. Its mere existence compels astronomers to confront the limits of their knowledge, questioning whether our current models of the universe can account for such anomalies. As scientists continue to study this peculiar galaxy, they grapple with the fear that NGC 1052 DF2 might be just the tip of the iceberg, a glimpse into a universe filled with exceptions that defy every rule we thought we understood. From this puzzling outlier, we now shift focus to its equally perplexing companion, NGC 1052 DF4, a galaxy that only deepens the mystery of dark matter's role in shaping the cosmos. With the next phase of the journey in sight, we encounter NGC 1052 DF4, a galaxy intrinsically linked to its companion, NGC 1052 DF2, yet equally confounding in its own right. Much like its celestial neighbor, DF4 presents a glaring anomaly to the conventional understanding of galaxies. It too appears to lack the mysterious dark matter that serves as the universe's invisible backbone. This makes DF4 not just a scientific puzzle, but a key piece in a broader controversy, one that shakes the very foundations of astrophysics and cosmology. If dark matter is as fundamental as we've long believed, how can two such galaxies existing side by side defy this universal rule? The enigma of DF4 has sparked a wave of theories, some more unsettling than others. One prevailing idea is that DF4, much like DF2, might have been stripped of its dark matter through gravitational interactions with nearby celestial giants. This could suggest that certain environments in the universe are capable of dismantling the intricate balance of matter and dark matter. On the other hand, some researchers propose that DF4 might have formed under entirely different conditions, hinting at previously unknown pathways for galaxy creation, ones that do not rely on dark matter at all. Could DF4 and its companion be outliers, or might they represent a previously hidden class of galaxies that have gone unnoticed until now? What truly excites and unnerves scientists is the prospect of what these discoveries might imply for the invisible forces shaping the cosmos. If galaxies like DF4 challenge the universality of dark matter, they also open the door to alternative explanations of gravity and cosmic structure. Some have even dared to speculate that phenomena like DF4 could signal the presence of exotic matter or previously unknown interactions at play, possibilities that lie beyond the scope of our current scientific models. These theories, while thrilling, also underscore how much remains unknown, igniting a mix of excitement and apprehension within the scientific community. As astronomers continue to examine DF4 in conjunction with DF2, they are confronted with a pressing question that cuts to the heart of modern cosmology. Are these galaxies rare exceptions, or could they expose fundamental gaps in our understanding of the universe? Whether through refined observations or innovative models, the study of DF4 is poised to reshape how we approach the mysteries of dark matter, gravity, and galaxy formation. As this chapter unfolds, it leaves us pondering the vast unknowns of the cosmos, setting the stage for even deeper investigations into a universe that constantly defies our expectations. Moving forward, we delve into the case of Tucana II, a galaxy steeped in dark matter but surrounded by questions that trace back to the very origins of the universe. Turning our attention now to Tucana II, we find ourselves exploring one of the most ancient and faint galaxies ever discovered. What sets Tucana II apart is not just its age or obscurity, but the massive halo of dark matter that surrounds it, far exceeding what one might expect for a galaxy of its size. This dark matter halo holds a staggering density, making it an unparalleled subject of study for scientists seeking to understand the primordial forces that shape the universe. The stars within Tucana II are few and faint, barely illuminating its shadowy presence. Yet it is precisely this scarcity of visible matter combined with its immense dark matter composition that raises profound questions. How could such an ancient galaxy retain such an extreme concentration of dark matter for billions of years? For researchers, Tucana II is more than a relic. It is a cosmic gateway to the earliest moments of galactic evolution. Its dense dark matter halo suggests it might have formed under conditions that existed shortly after the universe's birth, conditions that are no longer observed in more modern galaxies. This has led to theories that Tucana II could represent one of the first building blocks of galactic formation, offering a glimpse into a hidden era when dark matter played an even more dominant role in the universe's structure. But with this insight comes an unsettling implication. If Tucana II exists, how many other ancient, unseen galactic structures might be lurking in the vast darkness, cloaked entirely in dark matter and almost impossible to detect? The sheer density of dark matter in Tucana II also presents another layer of mystery. It suggests that galaxies like this might be outliers, or worse, they might be the key to a hidden population of primordial galaxies that defy current understanding. Such structures could have influenced the formation of larger galaxies and even shaped the cosmic web itself. However, their invisibility poses a significant challenge, leaving scientists grappling with the possibility that our current models of the universe might only be scratching the surface of a far more intricate reality. As we consider the implications of Tucana 2, we find ourselves once again reminded of the vast unknowns that surround us, setting the stage to continue our journey into the enigmatic world of dark galaxies. Moving ahead, we encounter Crater 2, a galaxy so elusive and faint it was almost missed entirely, challenging our very ability to uncover what lies hidden in the cosmic void. Shifting our focus to Crater 2, we uncover a galaxy so faint and elusive that it almost escaped detection altogether. Located near the Milky Way, Crater 2 stands out not because of its brightness or activity, but because of its sheer size and remarkable dimness. This galaxy is enormous, one of the largest discovered in proximity to our own galaxy, yet it emits so little light that scientists have nicknamed it the invisible giant. Its stars are spread so thinly across a vast area that it appears more like a faint smudge than a structured galaxy. The discovery of Crater 2 not only expanded the boundaries of what we consider a galaxy, but also highlighted how much of the universe might still be concealed in plain sight. What makes Crater 2 particularly unsettling is the implication of its existence. If a galaxy this large can remain so faint and hidden, it raises the question of how many others might be lurking undetected in the cosmic void. It is a sobering reminder of the limitations of our observational tools and methods. Astronomers typically rely on light to identify and study celestial objects, but Crater 2 defies this approach entirely. Its lack of brightness suggests that many more immense yet nearly invisible galaxies could be scattered throughout the universe, evading detection and quietly altering the gravitational dynamics of their regions. Adding to the mystery is the fact that Crater 2 is located so close to the Milky Way within a region that has been extensively studied. The idea that such a significant celestial structure could go unnoticed for so long challenges the assumption that we have a strong grasp of our galactic neighborhood. Some researchers speculate that Crater 2 may represent just the tip of the iceberg, a member of a hidden population of faint, ultra-diffuse galaxies that remain outside the reach of traditional surveys. If this theory proves correct, the implications are staggering. These galaxies, with their vast size and low brightness, could account for a previously unknown portion of the universe's mass, reshaping how we understand the distribution of matter on a cosmic scale. Crater 2 also forces scientists to reconsider the processes behind galaxy formation and evolution. Its faintness and spread-out nature suggest it might have experienced a different developmental path compared to more conventional galaxies. Perhaps it formed in an environment with limited star formation or suffered stripping events that left it devoid of dense, bright clusters. Whatever its origins, Crater 2 remains an enigmatic puzzle, urging researchers to refine their techniques and broaden their search for hidden giants in the universe. As we ponder the hidden possibilities surrounding this faint but massive galaxy, our journey continues with Segway 1, a galaxy so dim and sparse that its stars barely distinguish themselves from the cosmic dust around them. Now turning to Segway 1, we encounter a galaxy so faint that it nearly blends into the background of the cosmos. Considered the faintest galaxy ever detected, Segway 1 is an astonishingly sparse collection of stars, with most of its light barely distinguishable from the surrounding cosmic dust. Its discovery was not just a stroke of astronomical skill, but also a stark reminder of how elusive the universe's secrets can be. At first glance, Segway 1 might seem unremarkable, but beneath its faint exterior lies a shocking revelation. This galaxy is dominated by dark matter to an almost unimaginable degree. Segway 1 stars are so few and so dim that they barely contribute to its overall mass. Instead, nearly all of its mass comes from dark matter, an invisible and mysterious substance that does not emit, absorb, or reflect light. Scientists estimate that Segway 1 dark matter content is staggeringly high compared to its visible matter, making it one of the most extreme examples of dark matter-dominated galaxies ever documented. This discovery has profound implications for our understanding of the universe's composition and the role dark matter plays in shaping cosmic structures. What makes Segue 1 particularly unnerving is how it challenges conventional ideas about galaxy formation. In most galaxies, stars and other visible matter play a significant role in their creation and evolution. But Segue 1 defies this norm, appearing to be more of a dark matter framework with a sparse sprinkling of stars. This leads to unsettling questions. How did such a galaxy form? Could there be countless others like it, completely invisible to us? And what does this mean for our efforts to map the universe? The existence of such an extreme dark matter-dominated galaxy also raises concerns about our ability to detect and study similar objects. If Segue 1 hadn't been identified through its faint stars, it might have remained hidden forever. This suggests that there could be many more galaxies composed almost entirely of dark matter, silently influencing the gravitational landscape of the universe while remaining completely out of view. The implications are as fascinating as they are alarming. These hidden galaxies might hold the key to solving some of the biggest mysteries in cosmology, including the true nature of dark matter itself. Segue 1 forces us to confront a reality where much of the universe might exist beyond the limits of our current technology and understanding. Its extreme characteristics push scientists to rethink their theories and refine their methods, driving them to uncover the secrets of the unseen. With its faint glow and mysterious composition, Segue 1 serves as a haunting testament to how little we truly know about the universe. As we delve deeper into the enigma of these shadowy realms, our journey now leads us to the discovery of a newly recognized dwarf galaxy in the Fornax cluster, one that further complicates our understanding of dark matter and its pervasive influence. As we venture further into the cosmic unknown, our attention shifts to an intriguing discovery nestled within the Fornax cluster, a newly identified dwarf galaxy that has left scientists both fascinated and deeply unsettled. Unlike the luminous galaxies we are accustomed to, this dwarf galaxy seems to defy expectations by being almost entirely composed of dark matter, with a striking absence of the stars that typically define a galaxy's structure and brightness. Its presence challenges the very foundation of how we understand galaxies to form and evolve. Traditionally, stars serve as the building blocks of galaxies, their formation driven by clouds of gas that coalesce under gravity. But this dark galaxy appears to have bypassed that pathway entirely, existing as a ghostly framework of dark matter with only sparse or non-existent stellar components. The implications of such a discovery are profound and multifaceted. First, it forces astronomers to confront the idea that galaxies might not require significant amounts of visible matter to come into being. Could dark matter alone guide the formation of a galaxy, like an invisible scaffolding holding the universe together? If so, how many of these incomplete galaxies could be hidden in the vast reaches of space, overlooked because they emit no light? The Fornax cluster's dwarf galaxy is a stark reminder that our telescopes, no matter how advanced, can only reveal what reflects or emits light. Entire galactic neighborhoods may be missing from our cosmic maps, dark and silent but still exerting gravitational influence on the universe. This discovery also amplifies ongoing fears about the extent of our ignorance regarding dark matter. If galaxies like this one are widespread, it might mean that we have barely scratched the surface of understanding the full complexity of the universe's structure. What's more, it raises an unsettling question. If we cannot see them, how do we study them? These galaxies, composed almost entirely of dark matter, operate on rules that remain a mystery, defying the traditional laws of star formation and compounding the enigma of dark matter itself. Astronomers are both excited and unnerved by the implications. On one hand, the discovery opens a new frontier in cosmology, pushing the boundaries of human knowledge. On the other hand, it highlights just how much remains unknown, emphasizing the limitations of our tools and theories. The Fornax cluster's dark dwarf galaxy adds to a growing list of shadowy entities that seem to whisper at the edges of our understanding, urging us to look deeper and question more. As we grapple with these mysteries, our journey into the uncharted territories of dark galaxies continues to unfold, revealing a universe far stranger and more complex than we could have ever imagined. Turning our attention now to the Phoenix cluster, we find ourselves amidst one of the most perplexing cosmic phenomena ever observed. Known for harboring an unusually high number of dark galaxies, this cluster pushes the boundaries of what we thought we understood about the universe. At first glance, the Phoenix cluster might seem to be a vibrant hub of galactic activity, but delve deeper, and it reveals a concealed world of invisible structures. These dark galaxies, lacking the shining stars that make typical galaxies visible, challenge the very core of our understanding about how galaxies form and evolve. What makes the Phoenix cluster particularly mysterious is not just the presence of a few such galaxies, but their sheer abundance. Why are so many dark galaxies clustered in this one region of space? Scientists have long believed that galaxies form in areas rich with visible matter like gas and stars, yet here we find a collection of cosmic entities almost entirely composed of dark matter. This raises questions about whether the conditions within the Phoenix cluster somehow favor the formation of these enigmatic structures, or if other yet unknown cosmic mechanisms are at play. Could it be that dark galaxies were once more common in the universe, their remnants now concentrated in clusters like this one? Even more unsettling is the fact that these galaxies are virtually invisible, detectable only through the gravitational effects they exert on their surroundings. Their ghostly presence complicates our attempts to map the universe, suggesting that the cosmic framework might be teeming with dark matter structures we cannot directly observe. The implications for our understanding of dark matter, galaxy formation, and the overall structure of the universe are staggering. It hints at the possibility that what we see, stars, gas, and luminous galaxies, might represent just a fraction of what truly exists out there. The Phoenix cluster's dark galaxies also beg the question of their origin. Were they always this way, or did some catastrophic event strip them of their visible components, leaving behind only their dark matter cores? Each new study brings us closer to uncovering these secrets, but the answers are not yet within reach. The Phoenix cluster stands as a stark reminder of how little we truly know about the hidden forces shaping the cosmos. As we continue to unravel its mysteries, its dark galaxies remain a symbol of the unseen, waiting to challenge and expand our cosmic horizons. Shifting our gaze now to the Pandora cluster, officially known as Able 2744, we encounter another cosmic enigma that deepens the mysteries of our universe. This cluster, like a celestial graveyard, harbors ghost-like dark galaxies that elude direct observation. Their presence is inferred not through the light they emit, but through the gravitational fingerprints they leave behind. It is as though these galaxies exist as shadows of what we expect to find, immense in their influence yet cloaked in near-total invisibility. The Pandora cluster itself is a breathtaking tapestry of galactic activity, but beneath this apparent vibrancy lies a concealed realm of dark, hidden forces. What makes these ghost galaxies so haunting is their almost complete lack of luminous matter. They challenge the traditional understanding of what makes a galaxy. No dazzling stars, no glowing gas clouds, just vast entities dominated by dark matter. Imagine a structure so massive it warps the space around it, yet it remains entirely unseen to the human eye. Scientists have long speculated about the hidden mass in the universe, but the galaxies within the Pandora cluster seem to embody this concept in its most extreme form. They force us to confront the unsettling possibility that the universe may contain far more of these unseen structures than previously imagined. The very existence of these ghost-like galaxies raises urgent questions. Are they remnants of ancient galaxies destroyed by catastrophic events? Or are they unique formations born in environments that prevented the development of visible stars? These possibilities suggest scenarios both fascinating and deeply unsettling. For instance, if these galaxies were torn apart, what could have caused such devastation, violent galactic collisions, or the relentless pull of supermassive black holes? Alternatively, if they formed without stars, what unknown cosmic conditions could create such barren structures? These questions serve as both a tantalizing mystery and a chilling reminder of how much of the universe remains hidden from view. The Pandora cluster is a microcosm of the broader mysteries of dark matter. Its ghostly galaxies emphasize the need to rethink our understanding of the cosmos. They suggest that what we consider extraordinary might actually be an overlooked norm in the grand fabric of the universe. The fear lies not just in the unknown, but in the possibility that our maps, our models, and even our fundamental theories could all be incomplete. As scientists continue to study the Pandora cluster, its dark galaxies serve as a humbling testament to the limits of our knowledge, a cosmic whisper that there is still much more to uncover as we venture deeper into the unknown. Shifting our focus to the Tadpole Galaxy, officially named UGC 10214, we step into a cosmic drama where dark companions play a pivotal but unsettling role. This galaxy, known for its distinctive elongated tail, owes its peculiar shape to the gravitational interaction with surrounding dark galaxies. These unseen companions, largely composed of dark matter, subtly yet profoundly twist and distort the Tadpole Galaxy's structure, leaving behind a trail of stars flung across the cosmos. It is as if these dark entities operate as invisible puppeteers, shaping the visible universe while remaining cloaked in obscurity themselves. What makes these companions so troubling to scientists is the drastic impact they have on galactic evolution. Their presence introduces unpredictability into the long-held models of how galaxies form and behave over time. Imagine a grand cosmic dance where one partner moves with calculated precision, while the other remains an unseen force, erratically altering the rhythm. This interaction forces researchers to question how many other galaxies may have been shaped or reshaped by similar encounters. Could the Tadpole Galaxy be just one of countless silent victims of these dark companions? Even more concerning is the possibility that such interactions might not be rare. If dark galaxies like these are common, their gravitational influence could be rewriting the history of the cosmos in ways we are only beginning to grasp. The Tadpole Galaxy's companions suggest that dark matter is not just a passive, inert substance. It is an active agent capable of dramatically altering the visible universe. This raises profound questions. How many galaxies have had their histories rewritten by invisible forces? And what does this mean for our understanding of the universe's past, present, and future? The Tadpole Galaxy, with its dark companions, is a vivid reminder of how much remains hidden in the cosmic fog. These entities challenge scientists not only to unravel the mysteries of dark matter, but also to reconsider the entire framework of galactic formation and interaction. As research continues, the Tadpole Galaxy serves as a stark illustration of the delicate and complex balance of forces that govern our universe, and a sobering reminder that much of what shapes our reality remains unseen and enigmatic. As our journey takes us deeper into the cosmos, we arrive at the Virgo cluster, a vast congregation of galaxies that harbors an astonishing number of dark galaxies. Unlike the Tadpole Galaxy's dramatic story of gravitational distortion, the mystery here lies in what seems to be absent visible stars. Many of the dark galaxies within this cluster appear to have very few, if any, luminous stars, making them nearly invisible against the backdrop of space. Their existence is inferred not through light, but through the subtle gravitational fingerprints they leave on their surroundings. These faint traces have stirred a profound sense of curiosity and unease among scientists. The question of why these galaxies lack stars remains unanswered, sparking debates and theories that reach to the very core of cosmology. One possibility is that these dark galaxies failed to ignite the process of star formation, perhaps due to a lack of the conditions needed to turn gas into stars. Another hypothesis suggests that these galaxies might have lost their stars long ago, stripped away by interactions with the immense gravitational forces of the Virgo cluster. This raises yet another unsettling question. Could entire galaxies be rendered almost invisible through such violent encounters? What makes this phenomenon even more puzzling is that these dark galaxies still seem to possess significant amounts of dark matter, which acts as the scaffolding holding them together. This hints at an intricate relationship between dark matter and star formation, one that we are far from fully understanding. If dark galaxies are scattered across the universe as abundantly as they appear to be in the Virgo cluster, the implications are staggering. It would mean that much of the universe's structure is hidden, composed of unseen masses that distort our view of the cosmos. The Virgo cluster's missing stars represent a profound challenge to astronomers, forcing them to question their models of galaxy evolution and the role of dark matter in shaping the universe. These nearly invisible entities remind us that the cosmos is filled with secrets waiting to be uncovered, secrets that could redefine not only how we understand galaxies, but the very nature of reality itself. With this enigma at the forefront, one cannot help but wonder how much of the universe's story are we still blind to. With the next phase of our exploration in sight, we turn to a truly peculiar class of cosmic entities, galaxies that reveal themselves only through X-rays, remaining completely invisible in the spectrum of light we can see. These mysterious formations, often referred to as X-ray dark galaxies, are unlike anything we typically associate with galaxies. Instead of emitting the bright, twinkling light of stars or glowing in other wavelengths, these galaxies are detected exclusively through the high-energy X-rays they emit. This characteristic has made their discovery a groundbreaking and perplexing phenomenon in the field of astronomy. What makes these galaxies so intriguing is precisely what they hide. Imagine vast systems of matter, possibly rich in exotic materials, looming within the universe but eluding our sight entirely unless viewed through specialized instruments. This unique mode of detection implies that X-ray dark galaxies may harbor extremely hot gases, active black holes, or other dynamic processes that generate X-ray radiation. However, their lack of visible starlight raises a chilling question. Could there be an entire population of such galaxies scattered throughout the cosmos, completely veiled from ordinary observation? The possibility that such galaxies are hiding in plain sight complicates our understanding of the universe's structure. Most of our knowledge about the cosmos relies on visible light or signals from other well-understood wavelengths like radio waves. The existence of these X-ray-only galaxies suggests that our current methods of mapping the universe are fundamentally incomplete, potentially leaving vast areas unexplored. Even more unsettling is the thought that the structures we see, those shimmering spiral and elliptical galaxies we've come to recognize, might be just the tip of the cosmic iceberg, with X-ray dark galaxies forming an unseen backdrop that could dwarf what we currently comprehend. Moreover, understanding these enigmatic galaxies presents a daunting challenge to scientists. Their existence forces astronomers to rethink how galaxies form and evolve. If a galaxy can thrive by emitting only X-rays, it might indicate conditions so extreme or unique that they fall outside our existing models of galactic behavior. Could these galaxies be remnants of violent cosmic events, or are they built from entirely different components than the galaxies we are familiar with? As researchers work to uncover more about these hidden giants, one thing is certain: X-ray dark galaxies are a stark reminder of how much of the universe continues to evade our understanding. Their discovery not only deepens the mystery of the cosmos, but also highlights the vast limitations of human perception when it comes to exploring the infinite. If these galaxies are as common as some theories suggest, the universe might be far darker and more complex than we ever imagined. Shifting our gaze further into the cosmic abyss, we encounter the Coma Cluster, a vast and densely packed collection of galaxies that holds one of the most bewildering mysteries in astronomy. Hidden within this massive cluster are galaxies so faint and diffuse that they are nearly impossible to detect with conventional methods. These elusive structures have earned the nickname ultra-diffuse galaxies, and they are unlike anything we typically envision when we think of a galaxy. Instead of the bright, swirling formations of stars that dominate astronomical images, the galaxies in the Coma Cluster are ghostly shadows, their stars spread out so thinly that they appear barely distinguishable from the empty void of space. It is as though these galaxies are hiding in plain sight, cloaked by their own faintness. What makes the Coma Cluster's hidden giants so unnerving is their sheer size. Despite their dim appearance, many of these galaxies are astonishingly large, comparable in size to our own Milky Way. Yet, they contain only a fraction of the stars, making them incredibly diffuse and dominated by dark matter. This composition raises profound questions about their origins. How could such massive galaxies form with so few stars? Could they be remnants of galactic collisions or failed galaxies that never fully developed? Their very existence defies our current understanding of how galaxies are born and evolve. Adding to the mystery, the Coma Cluster is home to an unusually high number of these ultra-diffuse galaxies, far more than astronomers would expect to find in such a concentrated region. This overabundance hints at unknown processes shaping galaxy formation in dense environments, processes that may remain entirely hidden from our view. Scientists are beginning to suspect that these faint giants might not be unique to the Coma Cluster. If similar galaxies are scattered throughout the universe, lurking undetected in the shadows of cosmic structures, it would mean that a significant portion of the universe's mass and complexity is currently invisible to us. The implications are as fascinating as they are unsettling. These hidden giants challenge the reliability of our cosmic maps and the methods we use to measure the universe's structure. If we cannot reliably detect these massive yet faint galaxies, how many more secrets could still be concealed within the vastness of space-time? Their discovery has forced astronomers to rethink what they know about galaxy formation and prompted a deeper search for other dark and diffuse structures, not just in clusters like Coma but across the entire cosmos. The Coma Cluster's hidden giants stand as stark reminders of the limits of our observational tools and the vast, layered complexity of the universe we inhabit. Moving forward, we arrive at one of the most confounding enigmas of cosmic exploration: galaxies so featureless that they have been aptly dubbed blank slate galaxies. Unlike the vivid spirals or luminous bursts of stars that typically characterize galaxies, these celestial structures appear almost devoid of defining traits. They lack the bright star clusters, intricate patterns, or even the faint outlines of dust and gas that help astronomers trace a galaxy's formation and history. It is as though the universe has erased their story, leaving behind only a dim, unremarkable smudge amidst the cosmic canvas. What makes blank slate galaxies so unsettling is not just their appearance but their sheer obscurity. How did such barren formations come into being? Are they the remnants of galaxies stripped bare by violent cosmic events, like gravitational tides from larger neighbor galaxies? Or could they represent an entirely new category of galactic evolution, a pathway so unfamiliar that it escapes all current theories? Their unadorned nature challenges the very tools used to study them, offering no clear clues about their origins, composition, or trajectory in time. Perhaps even more intriguing is the profound implication of their existence. If galaxies can exist in such a primitive, featureless state, what does that say about our understanding of cosmic evolution? Could these blank slates be the embryonic beginnings of galaxies never having fully developed? Or are they ancient relics stripped of their vibrancy over billions of years, leaving behind only the faintest whispers of their former selves? Their discovery forces astronomers to confront an unsettling possibility. There could be countless other structures like these, hidden in the vast expanse, altering the unseen scaffolding of the universe. This revelation raises another critical question. How many of them have we overlooked? Blank slate galaxies could represent just the tip of the iceberg in terms of invisible or faint cosmic phenomena. If they exist in greater numbers than anticipated, their impact on our models of mass distribution, gravitational behavior, and even dark matter could be immense. Scientists are now turning to innovative methods such as advanced simulations and deep sky surveys in hopes of unraveling these mysterious entities. But for now, blank slate galaxies remain one of the most enigmatic puzzles in the universe's silent story, whispering that there is still much about our cosmos that lies beyond our grasp. As we venture further into the cosmic unknown, we find ourselves peering into one of the most hauntingly desolate regions of space, the Boots Void. Imagine an area so vast and empty that it spans hundreds of millions of light years, containing only a faint scattering of galaxies in what appears to be a near-total abyss. Yet within this seemingly barren expanse, astronomers have uncovered faint, isolated galaxies that defy explanation, their very presence raising unsettling questions about the structure and history of the cosmos. The Boots Void has captivated scientists not just for its sheer emptiness, but for the lonely galaxies that call this void home. These faint, distant structures seem almost misplaced, as if they are marooned in a sea of nothingness. Unlike galaxies in crowded clusters, which are shaped and influenced by their bustling neighbors, the galaxies within the Boots Void exist in eerie isolation. Their remote placement suggests a unique and puzzling process of formation, one that challenges our understanding of how galaxies evolve and interact with their environment. Even more perplexing is the question of why such a vast void exists in the first place. How did this cosmic desert come to be, and why are there galaxies scattered within it at all? Some scientists speculate that the Boots Void may have formed through the gravitational effects of dark matter, which could have swept material away over billions of years, leaving behind an unsettling emptiness. Others suggest that these faint galaxies might be remnants of a much older epoch, survivors of a time when the universe was younger and much different than it is today. The isolation of these galaxies carries profound implications. Their mere existence hints at an extraordinary resilience, having endured in a region with so few gravitational influences to shape their evolution. They may provide rare opportunities to study how galaxies develop in extreme conditions, untouched by the usual cosmic interactions that alter their structure and growth. However, they also serve as a stark reminder of how much we still do not know. Could there be other voids like Boots hidden in the vast blackness of the universe, harboring similar faint and solitary galaxies, or perhaps even something stranger? What is certain is that the Boots Void, with its lonely inhabitants, forces us to confront the vastness and mystery of the universe in the most unsettling way. It exemplifies the idea that even in the apparent absence of anything, there are secrets waiting to be uncovered, narratives written in the faintest of cosmic whispers. The Boots Void galaxies, though few and faint, challenge our most fundamental assumptions about the nature of the universe, urging us to rethink what we know about the hidden architecture of space itself. And with each new discovery, we are reminded that even the deepest voids of the cosmos are anything but empty. With the next phase of the journey in sight, we encounter galaxies so strange that they challenge our very definition of what a galaxy even is. These are the mysterious hydrogen cloud galaxies, vast cosmic formations composed almost entirely of hydrogen gas, yet mysteriously devoid of visible stars. Unlike the brilliant galaxies we often imagine, filled with luminous clusters of stars, these structures exist in a spectral in-between state. the hydrogen clouds remain uncondensed, leaving behind faint, starless voids that only deep scientific instruments can detect. These ghostly entities raise a troubling question. How many more invisible features might be lurking undetected in the universe? What makes these hydrogen cloud galaxies so unsettling is their refusal to follow the rules we thought we understood about star formation. Under normal conditions, hydrogen gas clumps together, collapses under its own gravity, and ignites nuclear fusion, birthing stars in a dazzling symphony of light and energy. But these dark regions stubbornly resist this process, remaining shrouded in obscurity. Could they be trapped in an ancient stasis, echoes of a primordial era in the universe, or are they governed by forces we have yet to identify? Some scientists speculate that dark matter may play a crucial role, its unseen presence influencing the dynamics of these clouds and preventing star formation. Yet even these theories leave us with more questions than answers. Perhaps most chilling is the implication that such oddities could be just the beginning. If galaxies composed entirely of hydrogen clouds can exist undetected, what other massive, unseen structures are quietly haunting the cosmos? Could there be entire regions of space hidden from view, populated by objects that evade our instruments and understanding? These invisible entities, though silent and seemingly dormant, might hold the keys to unraveling the universe's most profound secrets. However, their very existence is a stark reminder of how much of the universe remains unknown, eluding even our most advanced technologies. The discovery of these hydrogen cloud galaxies forces astronomers to confront the possibility of an unseen universe operating on rules we don't yet comprehend. They are a testament to the limits of human knowledge, serving as both a challenge and an invitation to explore deeper and question everything we thought we knew. As we continue our search for answers, one thing becomes increasingly clear. The universe, in its vastness, holds far more mysteries than we ever dared to imagine, lurking in the shadows and waiting to be uncovered. As we shift our gaze closer to home, shrouded in the shadows of the Milky Way, an unnerving possibility emerges. Hidden in the darkness, unknown dark galaxies or massive structures might be silently orbiting our galaxy, their presence eluding even our most sophisticated detection methods. Unlike the visible satellites of the Milky Way, these enigmatic entities emit no light, effectively rendering themselves invisible to traditional observation. Scientists suspect that their existence can only be inferred through their gravitational influence, a faint, ominous tug on the surrounding stars and gas that hints at something unseen yet profoundly significant. What makes these invisible companions so alarming is their potential impact on the stability of our galaxy. These hidden bodies, cloaked in dark matter, could exert enough gravitational force to disrupt the delicate balance of celestial orbits within the Milky Way. Over long periods, this might trigger shifts in the structure or dynamics of our galaxy, possibly altering the paths of stars or even influencing the developmental trajectory of the Milky Way itself. Imagine entire clusters of stars being subtly nudged and rearranged by forces we cannot directly see, their movements an eerie testimony to the silent presence of these cosmic phantoms. But the implications go far beyond structural disruptions. If such unseen entities exist near us, they may provide crucial evidence about the nature and distribution of dark matter. Their behavior could offer scientists a rare opportunity to study this elusive substance, shedding light on its mysterious properties and interactions. Yet, simultaneously, their existence also poses profound questions about the universe's hidden architecture. How many of these dark companions are out there, and how close might they be lurking? And perhaps most unsettling of all, could their influence extend beyond physical celestial movements, subtly steering the destiny of entire galaxies, including our own? The notion of dark galaxies quietly orbiting the Milky Way serves as a constant reminder of our incomplete understanding of the cosmos. It challenges us to think beyond the visible, urging us to explore the fundamental forces that dictate how the universe operates. These concealed entities, while hauntingly elusive, represent an invitation to delve deeper into the mysteries of space, encouraging us to embrace both the known and the unknown with unrelenting curiosity. And with each discovery, we edge closer to unraveling the profound secrets woven into the very fabric of our galaxy, shifting our focus to one of the most puzzling and captivating phenomena in the universe. Ultra-diffuse galaxies emerge as a stark contradiction to our typical understanding of galaxies. These cosmic giants, despite being some of the largest galaxies ever identified, appear eerily empty. Ultra-diffuse galaxies are faint, sprawling structures spread out over immense distances, yet they emit so little light that at first glance they seem like ghostly wisps against the backdrop of space. What truly astonishes scientists is their composition. These galaxies are believed to be dominated almost entirely by dark matter, with only a scattering of visible stars faintly glowing within their vast expanses. This overwhelming presence of dark matter is what makes them so enigmatic and deeply unsettling. Unlike traditional bright galaxies teeming with stars, these ultra-diffuse galaxies blur the boundary between what we consider visible cosmic structures and the invisible scaffolding of the universe. Their discovery has not only forced astronomers to rethink the rules of galaxy formation, but has also raised profound concerns about the role dark matter plays in shaping such colossal entities. If these galaxies can exist on such a grand scale, almost invisible to the naked eye, what else might be lurking out there, hidden in the depths of the cosmos? The sheer size of ultra-diffuse galaxies only deepens the mystery. Some of these galaxies rival the Milky Way in diameter, yet their faintness makes them incredibly difficult to detect. It's as if they're whispering their presence across the cosmos, challenging scientists to uncover their secrets. The fact that they are so faint yet so massive suggests an unusual evolutionary history. Did they form in isolation, far away from the violent interactions that typically fuel star formation in other galaxies? Or were they stripped of their stars through encounters with more massive, aggressive neighbors? Both possibilities lead to unsettling implications about the hidden mechanics of the universe, but perhaps the most alarming question of all is what their existence says about the unseen structures that dominate the cosmos. If ultra-diffuse galaxies can remain undetected for so long, how many more are still out there, quietly shaping the universe without our knowledge? Their faint visibility and immense size serve as a reminder of just how much of the universe remains hidden in the shadows, urging scientists to push the limits of observation and delve deeper into the unknown. With these mysterious entities, the cosmos seems to be revealing only a fraction of its secrets, leaving us to wonder what other colossal, invisible forces might be shaping the fate of galaxies like our own. And speaking of colossal forces, as we edge closer to the final chapters, we confront even more bewildering discoveries that redefine the boundaries of our cosmic knowledge. As we venture deeper into the unknown, our gaze shifts to the distant, dark giants lurking at the edge of the observable universe. These remote, massive dark galaxies defy every expectation, sitting like sentinels in the far reaches of space, where light struggles to travel and time takes on a different meaning. Unlike the ultra-diffuse galaxies that whisper their presence, these colossal structures stand as silent enigmas, their sheer existence forcing scientists to confront some of the most uncomfortable truths about the cosmos. Their vastness is staggering, spanning sizes that dwarf even the largest structures closer to home, yet they emit so little light that detecting them is an extraordinary challenge. What makes these distant dark giants so groundbreaking is not just their size, but how they upend everything we thought we understood about galaxy formation. In areas where the density of matter is assumed to be thin and cosmic evolution slows, these massive galaxies appear as paradoxes. How did they come into existence in such isolated regions, and what fueled their growth without the usual interactions that drive star formation? Some theories suggest that these galaxies might represent primordial structures, relics from the very early universe, built almost entirely from dark matter. If true, they are living fossils, offering a glimpse into a time when the universe itself was still in its infancy. But this idea comes with haunting implications. If such massive, hidden entities thrived billions of years ago, are there even more such structures beyond what we can currently observe? Their distances are another profound challenge. The light we receive from these galaxies has traveled for billions of years to reach us, meaning we see them not as they exist now, but as they were when the universe was young. This temporal distortion adds another layer of complexity, as the galaxies we study today may have evolved or even disappeared while their light was still on its journey to our telescopes. This raises an unsettling question about the limits of our observational tools. If we are only just beginning to detect these giants, how many more might lie even further beyond the edge of the observable universe, hidden by an impenetrable veil of distance and time? These distant dark giants not only challenge our understanding of galaxy formation, but also force us to reconsider the very framework of our cosmic models. They suggest that the universe might be far stranger and more complicated than our current theories allow, with forces and mechanisms at play that we have yet to comprehend. In their silence and isolation, these galaxies seem to be sending a message, a reminder that the universe is still full of mysteries waiting to be unraveled. And as we prepare to confront the final revelation in this journey of dark galaxies, we are left with the unsettling realization that the cosmos holds secrets far grander and more elusive than we ever imagined. As we approach the final chapter of this cosmic journey, let us imagine the uncharted territories of the universe that remain cloaked in shadow. The potential for future discoveries of unseen dark galaxies is both thrilling and unsettling, as they may harbor secrets that could completely transform our understanding of space and time. If the dark galaxies we have uncovered so far challenge the boundaries of science, consider the possibility of even stranger, more elusive structures still lurking beyond the limits of our current technology. These could be galaxies composed almost entirely of dark matter, with no stars or light to betray their presence, hiding in the vast expanses of the cosmic void, entirely invisible, except for their mysterious gravitational effects on surrounding space. Some scientists theorize that there could be galaxies so dark and diffuse that they evade even the most sensitive instruments we have today. These hypothetical entities might exist in regions of the universe we consider barren, quietly influencing the distribution of matter across billions of light years. Others speculate about structures beyond the observable universe itself, where the laws of physics as we know them could take on entirely different forms. If such galaxies exist, they might not just rewrite the rules of galaxy formation, but also hint at an entirely new chapter in the story of the cosmos, one in which dark energy, dark matter, and unseen forces are the dominant players. The implications of these potential discoveries are staggering. They suggest a universe that is far more complex, layered, and mysterious than we ever imagined. Perhaps dark galaxies serve as a bridge to understanding the early days of the cosmos, or perhaps they are evidence of phenomena we cannot yet comprehend, hints of multiverses, alternate dimensions, or entirely unknown forces at work. Every new discovery opens another door, but with it comes more questions. Where do these entities fit into the grand mosaic of space? Could they hold the key to understanding the ultimate fate of the universe? Or are they simply reminders of how much remains beyond our grasp? What is certain is that the pursuit of these hidden marvels will continue to push the boundaries of science, technology, and human imagination. The universe has always been a place of wonder and contradiction, revealing its secrets only in fragments. And perhaps that is the most humbling lesson of all. It is not just what we know about the cosmos that defines us, but our relentless drive to explore the unknown. As we leave behind the dark galaxies already discovered, we look ahead to the mysteries that still lie in wait, ready to redefine everything we think we understand about the infinite expanse above. With our journey across these 25 dark galaxies now complete, we find ourselves standing on the edge of understanding, staring into the vast unknown of our universe. Each of these enigmatic entities challenges the boundaries of what we know, from the ghostly structures near Andromeda to the immense, faint giants lurking at the edge of the observable cosmos. These galaxies hidden in the shadows force us to question our perception of space, time, and the very fabric of reality itself. Some are composed almost entirely of dark matter, defying conventional explanations, while others appear to lack it altogether, leaving scientists puzzled and theories in flux. Together, they weave a story of contradictions, a mysterious puzzle that combines awe-inspiring beauty with an unsettling reminder of how much remains unseen and unexplored. The implications tied to these celestial mysteries reach far beyond their immediate existence. They could hold the secrets to understanding the origins of the universe, illuminate the role of dark matter and dark energy, or even hint at laws of physics that remain undiscovered. Perhaps they are windows into other dimensions, or maybe they contain clues about the ultimate fate of everything that exists. What unites them all is their power to inspire, to provoke curiosity, and to remind us of just how small we are in the grand scheme of things. Yet, they also highlight humanity's unyielding determination to unravel the unknown, using every tool at our disposal to peer deeper into the mysteries of the universe. As we close this chapter, let us not forget that our cosmic journey is far from over. These dark galaxies are just the beginning stepping stones toward even greater revelations that await us among the stars. Their existence is both a source of wonder and a challenge to our intellect. What do you think these enigmatic galaxies say about the universe and about us? We would love to hear your thoughts, theories, or even your questions down below in the comments. If you enjoyed this journey through the cosmos, don't forget to like, subscribe, and hit the notification bell so you never miss an exploration as thrilling as this. Thank you for joining us, and as always, keep looking up, for the universe is filled with endless possibilities.